Hi, today we're going to be talking about factoring. And what it means to factor is to split up the expression as a product of its factors. So basically, you have the answer to what was multiplied together. Now you have to figure out what it was that was multiplied, if that makes sense. So if you look at example 1, we need to factor x squared plus 9x. That means, again, to put it into the, show it as a product of its factors. Now, there are 3 types of factoring, and if you recognize what type of factoring it is, it makes factoring a whole lot easier because then you have a goal in mind. So the first type of factoring you check for is greatest common factor. So you have to look at the terms, all the terms, and see if there is a factor or something that divides into both of the terms that I highlighted. And there is. There is an x factor in both of them. So if there is a common factor in both of them, that common factor will be pulled on the outside, and then you're going to divide it out of the terms and put the leftovers in the inside. You don't have to do this step, but for those of you guys who want to see what you're really doing is you're really dividing x squared by the GCF. That's the GCF. And x squared divided by x is x. And then if you divide it out of the second term, 9x divided by x is 9. Now, if you want to check yourself to make sure that you're right, you can remultiply x to both of them. X times x is x squared, and x times 9 is 9x. And you should always be able to multiply your factors back together to get out what you started with, which that does check out. So therefore, x squared plus 9x equals x times x plus 9. That is your factored form. Example 2, if I look at the factors of 4x squared minus 9, first thing I look for is to see if there's a common factor. And there are not. 4x squared and 9 do not have any factors in common. So that means that it's not a GCF type. And what other types are there? Well, if it only has 2 terms with a minus sign between them, it's probably going to be a dots type, which stands for, it's an acronym for the difference of 2 perfect squares. 4x squared is a perfect square because 4x squared can be written as 2x times 2x. That means it's a perfect square when you can write it into 2 factors that are both the same. And 9 is a perfect square. It's 3 times 3. So if there is a minus sign, I want to stress, dots has to have a minus sign. If this were a plus, this would not be factorable. If it's a dots type with a minus sign, then you're going to put the, basically it's the square root of 4x squared, the 2x. You're going to put that on the left of each set of parentheses. And then the square root of 9, the 3, goes on the right. And then you put a plus and a minus sign in each of them. And it does not matter which one you put the plus sign and which one you put the minus sign. So if you were to re-multiply this out, you would in fact get 4x squared minus 9. You can always multiply it out just as a double check. I'll just show you. That's 4x squared. That's negative 6x. Whoops. That's positive 6x. And the last 2 terms is negative 9. These 2 terms cross off, and there's your 4x squared minus 9. So this does check out. So we were right. That is your answer. Okay, the next term, example 3. Again, first you check for GCF. X squared, 5x, and 6. All of them do not have a common factor. Although there's an x in the first 2, there's not an x in the last term. So it has to be all or nothing. So this is not a GCF. It clearly doesn't have 2 terms. It has 3 terms. So if it's not a GCF and it's not a dots, then it's a trinomial type. 3 terms, tri for short, but trinomial means 3 terms. And when it has 3 terms, there are 2 types. There's all the ones that begin with a 1, and there's the ones that begin with a number other than 1. Example 4 is by far the hardest. But we'll start with example number 3. When it's a trinomial that begins with a 1, this is a special case. And there is a trick to this. All right, you have to multiply and get x squared as the first term. Well, that means it's x times x. There's your x squared. Now, to figure out what numbers go after those, it all depends on the last number. We have to multiply the last two numbers to multiply to make a negative 6. So now we have to think about, well, what multiplies to make a negative 6? Negative 1 times 6, positive 1 times negative 6. Also, 2 times negative 3, and negative 2 times positive 3. So because this begins with a 1, I don't have to go through a whole bunch of steps. All I have to do is figure out which one of these and only these pairs of numbers add up to negative 5. And 1 and negative 6 multiply to make negative 6, but add up to negative 5. Which is what I needed. So those are going to be my numbers that I'm going to put next to x. And it doesn't matter the order, whether I want to start off with the 1 or the negative 6, but I'll just go in order, x plus 1 and x minus 6. Again, if I re-multiply this, I should get back out what I started with. X times x is x squared. X times negative 6 is negative 6x. 1 times x is 1x. 1 times negative 6 is negative 6. And my two terms here are like. They add up to negative 5x, and then your minus 6. So this does, in fact, match. So I know that I am right with my factoring. And that is my final answer. This is my factored form of the original example. Okay, example 4 is not as easy. With example 4, it's a trinomial, but because of that front number 3, it makes life a whole lot complicated. I still have to multiply and get 3x squared, and fortunately there is only one thing that does that. It's 3x times x. So that's good. I only had one choice. But I can't just multiply and make 4 and try to add up to 7. I mean, I can try to list them all. How do I multiply and make 4? 1 times 4, negative 1 times negative 4. Okay, don't forget your signs. Two negatives also multiply and make a positive. 2 times 2, and negative 2 times negative 2. So those are my only choices. And if you notice, none of those add up to negative 7. And it's not going to, because what's happening is when I do my distribution, the 3x has to multiply with one of those numbers. So it's going to change one of those numbers and not stay that number anymore. That's why I can't just look at those numbers that make 4 right now, because the 3 is going to change that outer number. So this is just a guess and check now time. I'm just going to pick one, check it, see if it comes out to make that number, and if it doesn't, then try a new choice. So I'll start off with checking this. So if I put a negative 2 and a negative 2, now I'm going to check it. And I don't have to do a full distribution. I already know that the first two make 3x squared. I already know that the last two multiply to 4. All I have to do is check to see if the middle term comes out to be negative 7. So here goes. 3x times negative 2 is negative 6x. Negative 2 times x is negative 2x. And those two add up to negative 8. Close, but not negative 7. That's not it. Now, I can attempt to try to switch the terms around, but those two are the same number. So it's definitely not going to be that pair. So let me try maybe that pair, negative 1 and negative 4. All right, so let me try negative 1 and negative 4. Outer 2 multiply to negative 12x, and inner 2 multiply to negative 1x. And those two numbers add up to negative 13. All right, that's not negative 7. So let's try again. Now, I don't have to clearly get rid of this yet, because I can try switching the two numbers around. So instead of negative 1 first, make negative 4 first, and then negative 1 second. That is a different combination using those numbers. So let's try that. 3x on the outside times negative 1 is negative 3x. Negative 4 times x is negative 4x. And these two add up to negative 7. So I found it. This is my answer. These two will multiply together and make 3x squared minus 7x plus 4. So that is the answer in factored form. Now that's kind of tedious to have to go through all of those guesses and checks. So I'll show you one more time. Example 5, we want to factor that. And if I look, I can see that those terms have no factors in common. 6x squared, 13x, and negative 8. So it's not a GCF. So how do I factor this? Well, how do I get 6x squared? 6x times x is one way, but there's actually another way. It also could be 3x times 2x. So unfortunately, I have no idea which one right now is the correct even start of this. So this is why the guess and check is a little tedious, because now you have to check two different cases. We still have to multiply and make negative 8. So negative 1 and 8, positive 1 and negative 8, negative 2 and 4, positive 2 and negative 4. All right, those are my only numbers that multiply make negative 8. All right, so here we go. Let's try the first case right here. Let's try the 6x and the x with, I don't care, I'll pick one. This one. Now, automatically, I know that I'm wrong, and here's a little FYI. Since the original expression, I had a factor, didn't have a GCF in it, none of my factors should have a GCF in it. Right here, that factor has a GCF of a 2. So I'm not even going to bother checking this. It's not going to work because you can't magically have a GCF appear somewhere when the original didn't have a GCF. So I know that 2 and negative 4 are going to be wrong, and even if I switch it, I know it's going to be wrong because there'll still be a GCF in it. So it's definitely not those two. All right, so let's try maybe 1 and negative 8. I know enough not to put the negative 8 with the 6 because that'll make a GCF again. So I'll try this. Okay, my outer 2 make negative 48x, and my inner 2 make 1x. And that adds up to negative 47x if I add up these two. So that is way wrong. So that is not going to be it. And I'm out of options now. So that means that the 6x case wasn't the correct case. All right, so let's go back to the drawing board and now try the 3x times 2x case. All right, I'll go back to this. Again, I'll try my positive 2 and my negative 4. But I'm not even going to bother checking it again because I'm running into the same problem. That has a GCF in it, so I know enough that that can't be the right answer. All right, so if I try to switch it, I'm still going to have a GCF. So that's not it. All right, so next case. Let's try then moving up to this one. All right, so I'm going to try to put, well, not the 8 with the 2. So let me put a negative 8 here and a positive 1 here. And if I check, my outer 2 multiply to 3x, and my inner 2 multiply to negative 16x. And these two add up to negative 13x. Oh, but I need a positive 13x. Well, that means it's probably then the other case where the signs are switched. So I'm going to now switch the signs and make it a positive or negative 1x or negative 1 and a positive 8. So the outside is going to be, oops, I reversed my numbers too. That's wrong. Okay, my outside's going to be negative 3x, and my inner 2 are positive 16x, and these two add up to positive 13x. So I did it. That took a little while. Now, as you do the guess and check more and more, you'll find it becomes a little easier. You see what to look for, but it is a little tedious. So instead of doing it that way, and I purposely took the long approach to that. I actually knew what the answer was, but I wanted to show you as a beginner, it's going to take you probably that long to figure out the answer. The AC method, method 2, is another way to do trinomials, that these harder types, and it's a process that always works. That's why I find a lot of kids like this process better. So if I write down the original problem again. Okay, so for this process, it's kind of like what we did, but better. What we're going to do is we are going to not even start with parentheses. We are going to first multiply what's called the A number and the C number. Okay, the letters go in order, A, B, C. So the A number is 6 and the C number is -8. And we are going to multiply. So A is 6, C is -8. And you're going to multiply 6 times -8. That's why we call it the AC method. And we're going to now try to list out all the factors of -48. So -1 and 48, +1, -48, 2 and -24, -2, +24, 3 and -16, -3, +16, 4 and -12, -4, +12, 6 and -8, and -6 and +8. Now, I know a lot of you guys may not have known the factors that easily, so I have a way out for you. For the most part, a lot of you guys try to figure out factors by guessing and checking. So you'll do 48 divided by 2 and see that that works, and 48 divided by 3 and see that that works, 48 divided by 4 and that works, 48 divided by 5. And then that doesn't work because that's a decimal and we want whole number factors. So instead of doing all this, if you notice, all you're doing is changing the bottom number each time, what you're dividing by. And that in mathematics is what's called a variable. So if I use my smarts about it, I can let the table do all the work. I can go to my y equals and do 48 divided by what number. And that's exactly what I'm asking the calculator. And if I go to my table, you'll notice that all of my pairs are going to come out. There's my -1 and -48. There's my 2 and 24. There's my 3 and 16. My 4 and 12. My 5 didn't work. There's my 6. And if you do it this way, you can just go to your table and scan it without writing them all down. So I'll do that especially for example 6. I'll do it that way only and show you how much nicer it is. All right, so now I have to figure out which pair of factors of -48 now, not the -8, but which pair of factors of -48 now add up to my 13. So if I scroll my table, I see that -3 and 16 add up to equal 13. So what we're going to do is we are going to keep the 6x squared, but now we're going to split 13x up into the two numbers we picked, so -3x and +16x, and then keep the -8. So all we did was split the middle term. That still makes 13x, but it just looks different. Now we're going to create two groups, and we're going to do the GCF out of each group. Okay, so the GCF out of the left group, there is a 3 in common and an x in common. So 3x comes out, and then when you divide the 3x out of each term, the leftovers stay inside the parentheses. So 2x minus 1. All right, in the right group, what's the GCF of 16x and -8? A +8 is a GCF. Now notice I have to have a sign here. So if you take out a positive number, you put a plus there. If you take out a negative, you put a negative there. All right, so if you divide out at 8x, you get 2x for the first term and a -1 for the second term. And now if you notice, both of the sides have a 2x minus 1 in it. So basically we're going to pull the 2x minus 1 out of each group. And again, what we're doing is we're actually pulling out a GCF. So a common mistake is students want to write that twice. But we're taking it out of the left group, and there's a 3x left. And we're taking it out of the right group, and there's an 8 left. And there is your factoring. And if you notice, that matches up there. It's in reverse order, but remember, multiplication is commutative, so they can be in the reverse order. All right, so I know it looks really hard now, but as you do this, I really find a lot of students like the AC method because it's a process that always works. There's no guessing and checking involved. So for the sake of time, example 6, I'm not going to do the guess and check method. I'm just going to stick with the AC method. Okay, so for the AC method for number 6, first off, I'm going to write my expression again. All right, so I need to figure out what multiplies the AC multiply to make 60. All right, and again, instead of sitting here and figuring out what multiplies to 60, I can let my calculator do the work. All right, going to my y equals, I want to know what divides into 60. So 60 can be divided by what? Now I check my table, and then I'll have every single pair in front of me. So all I have to do now is scroll my table and see which pair, 1 and 60, 2 or 30, 3 or 20, add up to negative 19. Well, these are both positive, so both of these pairs are going to add up to a positive 19. So I need to go back. Okay, negative 4 and negative 5 multiply together to make negative 60 or positive 60, but they add up to negative 19. And again, if you really want to sit here and figure out the factors, you can. I mean, you can get your table and then write your numbers down, but it's right here. These two make negative or add up to 19. So now what we're going to do is we're going to split those two up into negative 4x and negative 15x. You're going to keep the first and last terms. Okay, and now I'm going to create two groups, and I need to take the GCF out of each group. So the GCF out of that group would be a 2 and an x. And if I divide a 2 and an x out, I get a 5x and a negative 2. For the second group, what's the GCF? There is a 3 in common, but there's also that ugly negative sign there. We have that first term of the second group has to be positive. If not, you need to divide out a negative as well. So that's when you have to divide out a negative. So if I divide out a negative 3, I'm going to get a positive 5x to make 15x, and I'm going to get a negative 2 because a 6 divided by a negative 3 is a negative 2. All right, now looking at my parentheses sets, I have 5x minus 2 in both of them. That's how I know I'm on the right track. That means I'm going to pull that out in front, and the two other guys come together. And that is your answer. So again, save a whole lot of time compared to guessing and checking. All right, one last problem. The last problem, the directions say to factor completely. If you ever hear that phrase, factor completely, that implies that you will factor more than one time. And at your level, it's going to involve GCF and then either dots or tries. In upper level math, it can actually be 2 dots or etc. So if we look at all the terms, all 3 terms have a 2 factor and an a factor in it. So therefore, we're going to pull out a 2a out of all the terms. That leaves you with an x squared, a 12x, and a 20. Then you look to see the leftovers. Okay, you look to see if you can factor that again. And that is a trinomial type that begins with a 1. That was our easy case. You don't have to go through the AC method with that. All we have to do is figure out what multiplies to 20 and adds up to 12. 1 and 20, 2 and 10. Okay, and the one that adds up to 12 is our 2 and our 10. So with the one trinomial types, don't go through the AC method. It'll just end up being those two numbers anyways. And there's your factoring.